Hi, welcome to the Tech Zone. Today we are going to explore the performance gain by using external graphics, something that is possible only if you have a laptop equipped with one USB-C Thunderbolt 3 port or Thunderbolt 4 port. What you will need is an eGPU and a graphic card. An eGPU can be bought for around $300 or less if it's used. I have the new RTX3080 card that gives a lot of power for the money and can be purchased for around $700 at NVIDIA's website. The new Dell XPS 15 is an amazing piece of hardware, excellent screen, excellent keyboard and trackpad, but the main attraction is the display and the hardware surrounding it. Check out the bezels, it's not only the sides that are thin, even the top bezels is small and still hosts a Windows Hello camera. So this is my eGPU that hosts an RTX 3080. I have several eGPUs, and this is the most reliable and most well-equipped machine that I have ever bought. The greatest advantage with this model is that it has two Thunderbolt 3 circuits, one handling different I/O and the other handling the graphic processing, and that results in a problem-free environment. The power supply by eGPU is enough for charging the laptop and still utilize the graphic card at 100%. It's also space for an external SSD inside for storage expansion if you like. Connecting to the eGPU is very easy when you have done the initial pairing process. Just attach the Thunderbolt 3 cable and wait for a few seconds and the screen lights up and nothing else needs to be done. It takes around 5-6 seconds and you can see the screen lights up. So I have the keyboard also connected to the eGPU, and as you can see it works perfectly. So before going through the benchmarks, I would like to see your comments regarding the setup, and I will be very grateful if you can support the channel by subscribing. And a thumbs up will be very, very much appreciated. The first performance test is 3DMark's Firestrike that is divided into 3 parts. I will run the first test on the laptop screen by looping back the data from the eGPU. This will give a lower total score than on an external monitor where the signal just have to travel once through the Thunderbolt 3 cable. So here is the scores for Firestrike. You can see 19,104. That's a very, very good result. Of course we have losses as we are looping back to the laptop, and you will soon see the figures regarding presenting this test on an external monitor. Here you can see the temperatures, and you can also see the CPU frequency is quite good. It's only a little dip at the CPU test, and that's totally normal. And you can also see very high temperatures on the last 2 tests. And that's an issue, of course, on this light laptop. But here is the scores when running the test on an external monitor. And you can see it's a lot better. It's almost 2,000 points. So this is TimeSpy by 3DMark, and we will only run this test on the external monitor, as we already have seen the results, the degradation we have when running on the laptop screen. So you can see the results here. It's also very, very good result, 12,165. I need at least an i9 9900K CPU to get a better result, and then with RTX 2080 Ti. But you can see here also it's the same story here. It's very high temperatures during the CPU test, and otherwise it's okay. It's around 70 degrees on the normal tests, and that we will see also in when we are going to try Far Cry 5 and check the CPU and GPU performance on that game also. So let's move on to Far Cry. We will set the highest resolution and the maximum settings available on this game. And here you can see the temperatures. They are hovering around 92, 99, up to 100 degrees sometimes. But the at this resolution, I think around high 70s and 80s are very impressive during this game. I have tried it to run this also on the laptop, and we will lose around 15 frames per second by looping the signal back. So it's the CPU that is running hot here, and what will happen is that the system will throttle and then lower the voltage to the CPU, and that will lead to much lower temperatures, around 75 degrees Celsius. And that will not affect the frames per second, not a bit, as far as I can see, maybe very, very little. So now you can see it's down to 75, 60, high 60s and 70s. And you can see it's still 72 frames per second, and that's really good, actually. I would have preferred that the throttling and the lowering of the voltage could have been done a little bit earlier in this process. So what do you think about this? Is this an attractive solution for you? And as I said before, please subscribe to the channel. It would really help me a lot, and I will be very, very grateful. And give it a thumbs up if you find it useful. Thank you very much for watching. See you in the next video. Bye bye.